Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. Here we have PicKit 3 programmer, and we'll use this programmer to download hex file in microcontroller. Here we can find a 6-pin female header connector. To connect this programmer with hardware, that is microcontroller, and this arrow is showing that the right side is pin number 1, and on the other side of this programmer we can find a mini USB interface to connect this programmer with computer. Now we'll see the pin details of this header connector. Here we can see the pin number 1 is master clear, pin number 2 is VDD, that is 5 volt, pin number 3 is VSS, that is ground, pin number 4 is PGD, pin number 5 is PGC, and pin number 6 is PGM. Here we can see in the schematic diagram we have pin number 1, that is master clear, and we have connected a 100 ohm resistor from pin number 1 to the master clear connection. Second pin is 5 volt, that is 5 volt of microcontroller. Third pin is ground, and fourth pin is connected with RB7, and here we can find the RB7 is PGD, and pin number 5 is connected with RB6. Here we can see the RB6 is PGC. So we'll connect this programmer with the help of 5 pins with our microcontroller. To develop the interface of PicKit 3 programmer with microcontroller, we will use these header pins to connect all 5 pins with microcontroller. Before wire wrapping the interface for PicKit 3 programmer, first we will see the position of LCD. We will place these header pins outside of this LCD. Here we will place the male header pins for PicKit 3 programmer so that we could easily connect PicKit 3 programmer with our circuit. Now we'll wire wrap these male header pins with microcontroller and VCC and ground. Here we can check the pin number 1 for PicKit 3 programmer is on right hand side of this connector. In this case, rightmost pin will be master clear for microcontroller. We'll connect a 100 ohm resistor with pin number 1 of PicKit 3 programmer and pin number 1 of microcontroller, which is master clear input for microcontroller. Now we'll use wrapping wire to connect all 5 pins of PicKit 3 programmer interface with microcontroller. Now I'll pass the wire from the bridge. Now we'll check the continuity of pin 1 of PIC 3 programmer with 100 ohm resistor. Here we can check pin number 1 is connected properly with 100 ohm resistor, and second end of this resistor is connected to pin number 1 of microcontroller. In similar way, we'll connect other pins of PIC 3 programmer with microcontroller and VCC and ground. Pin number 2 will be connected with 5 volt, and here we can find we have 5 volt connected with this 10K resistor, which is a part of power on reset circuit. Now we'll connect the pin number 3 of this programming interface with ground, and here we can find the pin number 1 of LCD is ground. So we'll connect pin number 3 of this connector with pin number 1 of LCD. Pin number 4 of this programming interface connector will be connected to pin number 40 of microcontroller, which is PGD connection for programming interface. Pin number 5 of this programming interface will be connected to pin number 39 of this microcontroller, which is PGC connection for this programming interface. Now we have wire wrapped all 5 pins required for PIC-3 programming interface. Now we'll connect pin number 1 of this LCD connector with ground. In this way, we'll connect pin number 3 of programming interface with ground. Here we have ground connection on back side of Vero board. We have connected pin number 1 of LCD connector with ground. Now we'll check the continuity of PIC-3 programming interface with other pins of microcontroller and VCC. Pin number 1 of PIC-3 interface is connected to 100 ohm resistance, which is connected to pin number 1 of microcontroller, which is MCLR, that is master clear. Pin number 1 is connected to 100 ohm resistor, and second end of this resistor is connected to pin number 1. Pin number 2 is 5 volt. I'll check the connection directly from the output of LM7805. Okay, pin number 2 is connected to 5 volt. Pin number 3 is connected to ground. Okay, pin number 3 is connected to ground. Pin number 4 of PIC-3 interface is connected to pin number 40 of microcontroller, which is PGD connection. And pin number 5 is connected with pin number 39 of microcontroller, which is PGC pin of microcontroller. Okay, our programming interface is completed. Now if we'll insert the microcontroller into the base, and if we'll connect PIC-3 programmer with microcontroller, it means that PIC-3 programming interface will detect the microcontroller as PIC16F877A microcontroller. First, I'll insert the microcontroller into the base. Please take care, pin number 1 is on left side of this microcontroller. Here we can find a notch and a dot. This dot shows that this pin is pin number 1 of microcontroller. Now I'll connect PIC-3 programmer with computer. By using mini USB interface connector, I'll connect the PIC-3 programmer with the computer. Here we can see PIC-3 programmer is energized. Now I'll insert the PIC-3 programmer in Vero board. Now I'll run the software for PIC-3 programmer, and the program will automatically detect that a microcontroller, that is PIC16F877A, is connected in circuit. Here we can see the software has detected that PIC16F877A microcontroller is connected in circuit. Now we can develop different circuits for our prototype, and we'll check them step by step as we will develop these circuits. We'll start our circuit from simple LED interface, and we'll go for complex circuits, that is 8 LEDs, multiplex 7 segment displays, LCDs, firing angle controls and other circuits.